Okay, this video is a quick introduction to how hypothesis testing works in science. So, to start off with, in a hypothesis test, you need a hypothesis. So let's just take a simple example where you're comparing groups, and this is group 1 and this is group 2, and say we're comparing body size. You've gone out and observed these two groups and said, I observed that they seem to differ in their average body size. And I'm going to hypothesize then the groups differ in body size. However, what you're doing in a statistical hypothesis test is not actually evaluating this, but evaluating a null hypothesis. This is often abbreviated H0, and this is that the groups do not differ. Now, if your null hypothesis is supported in the end, what you're expecting is when you go out and measure the individuals from groups 1 and 2, that it's the same as drawing individuals from one large distribution with a single mean. So instead of looking like this, with two separate means, one for each group, the groups are not different, and it's the same as drawing individuals from one unique population. So this is the distribution of groups 1 and 2. Similarly, if your hypothesis deals with the relationship between two variables, so let's just say variable x and y, we can call this size, body size, and head size. You may have gone out and observed individuals and said, it looks like head size seems to vary with body size. So as individuals get bigger in body size, their head size similarly increases. So your hypothesis might be that, well, as you measure individuals, you should expect some positive relationship between body size and head size. However, just like in the previous example, the null hypothesis is what you're actually going to be testing. And so your hypothesis, as you've observed it, would be head size increases with body size, but the null hypothesis is there is no relationship between head size and body size. So the null hypothesis is going to look like this, where there's no slope. As you increase in body size, or on this x-axis, there's no change in the y-axis. So there's no relationship between the two. So in hypothesis testing, if you're looking at the relationship of two variables, you are evaluating this hypothesis. Where this is important is when you talk about the probability values that are generated from a statistic. So, and often when you're talking about statistics, you see this all-important p-value. The definition of the p-value is the probability that the null hypothesis is true. Note, the p-value does not actually have anything to do with your actual biological hypothesis, but is only based off of the null hypothesis. So a p-value is going to vary between a value of 0 and 1. So a value of 1, if we put this in here, 1 would be 100% probable that the null hypothesis is true. What does that mean with regard to whether there is a difference between groups or a relationship between two variables? It means that there's no relationship, or there's only one group, not two distinct groups. That is, it's 100% probable that this is true, and this is, going back, there is no relationship, and or the groups do not differ. So in fact, you're more likely to reject the null hypothesis as it decreases towards 0. Now there's a statistical convention that a p-value, if it is less than 0.05, is a threshold for rejecting your null hypothesis. So this is, there's a 5% probability that the null hypothesis is true. Alternatively, there's a 95% probability that the null hypothesis is false. That is, that there is a 95% probability that either there is some relationship between two variables or groups tend to be different rather than the same. So as this goes below 0.05, we start to be able to say that there is a significant difference between groups or relationship between two variables. So that's a quick introduction to the basics of hypothesis testing.